Welcome, folks. Before us, we have a question from physics, and this question is under the gas law. So let's read through. In a certain time, when the temperature was 27 degrees Celsius and the atmospheric pressure was 99,000 Pascal, a 300 cubic centimeter container was sealed. The container, which contained only air, was placed into a refrigerator until its temperature cooled to 5 degrees Celsius. Calculate the new pressure in the container. Right, so let's first collect the data. Right, so we'll first deal with the first temperature. So consider this one as temperature 1. Now, whenever you are given temperature in degrees Celsius, make sure you convert that into Kelvin. So 27 plus 273. So you always add 273. Then you get 300, which is in Kelvin. Then temperature 2 is 5 degrees, so plus 273, giving us 278 Kelvin. Then from there, let's look at the pressure. So pressure 1 is this number here, 99,000. Now for pressure, it doesn't matter the units that you are given. Then the question is, calculate the new pressure. So we are solving for pressure 2. Now, if you look at the volume, so we only given one value and we are not asked to find the second value about volume. So we'll say volume is constant. So if volume is constant, make sure it is not part of your calculations. So now, under which law is this question coming from? So this question is coming from the Gay-Lussac'S law. Now, this law states that the pressure of a fixed mass of gas is directly proportional to its temperature as constant volume. So the relationship between the temperature and pressure is that these two are directly proportional. So if one factor decreases, then the other factor must also decrease. Then the formula under the Gay-Lussac'S law is pressure 1 over temperature 1 is equal to pressure 2 over temperature 2. Now, let's say if you forget this formula during your exams or tests, what are you supposed to do? So what I recommend you do is at least master this ideal gas equation, which is P1 multiplied by V1 over T1 is equal to P2 times V2 divided by T2. Now, from this formula, we can make Charles' law, Boyle's law, even Gay-Lussac'S law. So what is important is you cancel the factor that is constant. So let's cancel volume. So we cancel V, we cancel V. So we can see that we have P1 over T1 is equal to P2 over T2. So that is what you're supposed to do in a case where you forget. So now we can substitute. Pressure 1 is 99,000 Pascal over temperature 1 is this number 300 Kelvins. Then pressure 2 is what we are solving for. Then temperature 2 is 278. So 278 Kelvins. Then we cross multiply. We have 300 K pressure 2 is equal to, so we are going to multiply 99,000 times 278. So I'm getting 27,522,000. Then Pascal this, then times this K. So you divide by 300 Kelvins, even here by 300 Kelvin. So if we cancel, we'll have P2 is equal to, so this cancel, divide by 300. So I'm getting 91,740 Pascal. So we can see that the pressure also decreased because the first pressure was 99,000, but the second pressure was 91. as temperature also decrease. The first temperature is 300, the second temperature is 270. So we can see that the temperature decrease, so is the pressure. Therefore, we have the relationship of directly proportional. So that's it for this video. Thanks for watching.